So today we'll be learning about how to solve different equations that have x in the position of the exponent or in an exponential position. So the three questions we'll be looking at today are 9 is equal to 5 to the power of x, 5 is equal to 9 to the power of x minus 1, and finally 5 is equal to x to the ninth power. So as with all equations, our first step is to get x by itself, or that's our purpose. And the way we usually do that in other equations is by doing the opposite of whatever operation is happening. So if our operation was, for instance, addition, if it was x plus 1, our opposite would be subtracting 1 from either side because subtraction is the opposite of addition. If it was y is equal to 2x, then the opposite of that would be dividing by 2, since division is the opposite of multiplication. So for our question, where x is in the exponent, for instance, y is equal to 2 to the power of x, the question is, what's the opposite of an exponent? And in case you couldn't tell by the title, the opposite of an exponent is a logarithm. So in order to get rid of this base of 2 and to get x all the way by itself, we would just have to multiply each side by log of 2. So we would multiply log of 2 by 2 to the power of x, and we would get x by itself. So we're going to be using this principle to solve the problems that I showed previously. So let's start with the first one. A is 9 is equal to 5 to the power of x. So like I said, the first step is to try to get x by itself. And we can do this by multiplying each side by log of 5, since our base is 5 and we want to get rid of that. So once we do this, that should cancel out the 5, leaving us with just x is equal to log 5 of 9. So now comes the problem of calculating what log 5 of 9 is. If you look at your calculator, you'll most likely have a log button, but a standard log is the log of 10. So on a normal calculator, unless you have a fancy one, you won't be able to find out log 5 of 9 unless we write it a different way. So we can actually write log 5 of 9 as a fraction of log of 9 over log of 5. And the way that I remember this is that since 9 is the larger number here and it's farther away from the exponent, it should go on top. And since 5 is the smaller number here and it's right next to the exponent, it's very small, it should go on the bottom. So once we get these two numbers, we calculate the values for them. For log of 9, you should get a number around 0.94. And for log of 5, you should get a number around 0.69897. And once you divide this, you should get somewhere near 1.36 as your final answer for x. So just to verify that we're doing this right, let's plug 1.36 back into our equation. So let's do 9 is equal to 5 to the power of 1.36. So if you put this into your calculator, the answer you should get is 8.925, which is about equal to 9. And so this proves that we did our equation right. And the reason it's not exactly equal to 9 is because of the rounding we did when we got the logarithms. So if you want the most accurate answer, I would advise you to not round until the end. However, since I'm writing this down, I can't really write down a 10-digit decimal, so I'll just be rounding in my video. So now that we've done that, let's move on to our next problem. B, 5 equals 9 to the power of x minus 1. So this problem is very similar to our previous problem, and being that the first step we want to do is try to get the part in the exponent, x minus 1, by itself by getting rid of the base. So once again, we're going to do this by multiplying by the logarithm. In this case, we're going to multiply by log 9, since our base is 9. And once this is done, our 9 will cancel out, and we'll be left with x minus 1 is equal to log 9 of 5. So once again, we're going to write log 9 of 5 as a fraction. We're going to write it as log of 5 over log of 9 is equal, and so, yeah, log of 5 over log of 9. And the reason we're doing this, once again, the way you can remember, is because since 5 is the larger number, it should go on top, and 9 is small and right next to logarithm, so it should go on the bottom. And for log of 5, you should get a number around 0.69897. And for log of 9, you should get a number around 0.95424, which is equal to 0.732. So now we have 0.732 is equal to x minus 1. And the way that we get this, now the next step we have to do is add 1 to both sides, because since x isn't fully by itself, there's a minus 1 there, we have to get rid of that by adding 1 to both sides. So for that, we should get 1.732 is equal to x as our final answer for that question. And now let's move on to our last question, C, which is 5 is equal to x to the power of 9. And this question is a little bit different than the previous ones because in this one, x isn't in the exponent, 9 is, and x is the base. So this one we will be solving a bit more like as if it were 5 is equal to x squared, or if it was 5 is equal to x cubed. In those type of problems, you simply take the cube. For instance, if it was 5 is equal to x squared, you would just take the cubed root of x cubed, which would give you x, and the cubed root of 5 would be equal to x. So with 9, it's the same way. We have to take the ninth root. However, since most calculators don't have a ninth root function, we can do this using cubed root by breaking x cubed into, or by breaking up x to the ninth into x cubed times x cubed. So first we'll take the cubed root of our right side, and we'll also take the cubed root of each. We'll take the cubed root of each side of this equation, and you should get x cubed is equal to 1.7. And now that we still have one more x cubed, we once again take the cubed root of that answer, and we will get x is equal to 1.196 as our final answer for problem C. So just to recap of what we learned in this lesson, we've learned how to simplify an equation when x is in the exponent, and also what to do when we have a larger power than 2 or 3. That is, when x is being multiplied to a larger power than 2 or 3, such as 9, we learned that we can just break it up into smaller powers and use the square root or cubed root in order to get rid of those numbers. So that concludes today's presentation. Thank you for watching.